Continuing, here we go with the 2023 10A, problem number 19. The line segment from A12 to B33. Pause and graph those things. Don't know what you're doing, you're not sure what transformed. Let's get a visual on it because your brain's going to process the visual and give you more options in your thought process. 1, 2, there will be A, and 2, 3, 3. No graph paper allowed. You will have to graph your own. So 1, 2 to 3, 3, something like this. And that's going to be transformed to the line segment. So it's segment to segment from A prime 3, 1 to B prime 4, 3. Let's see, 4 about here, I guess, and 3 here, B prime. And that's what it's going to look like. Maybe a little bit longer on this one, I guess. Let's see here. They don't quite look like my scale's good, probably because I'm drawn from the side here. There we go. They look close enough, right? Just pretend. Next, sending A to A prime and B to B prime by a rotation centered at the point P, S, T, which I would never use because S looks like 5 and I don't like that. So I'll probably just call it XY when I do it. And that's what I did on my paper as well. What is the positive difference in the coordinates of that point? Again, when you read something, do not read absolute value of S minus T. You are being directed by the way they wrote it to read it that way. Instead, try to roll it to a different perspective to look. It might give you different ideas about how to approach things. What is the positive difference in the coordinates of P? Different ways to frame what it's saying might unravel shortcuts or techniques. So this was one of the ones that I skipped originally. I mean, I did it for a little while and I could not think of what to do. And as I'm fumbling through, different kinds of thoughts, it does eventually dawn on me something really obvious that makes the problem fairly trivial from that point. And that is, first we'll just start with my process. I started by trying to guess, approximately where the point might be. I mean, B, these are on the same line, right? One is at 3, 3, and this is at 4, 3. So I want to use an undo button on my Zoom screen, but don't have that here. So you've got to have a point somewhere up here, right? Maybe something like this. So I was like, well, if I went at that angle and then A did the same angle here. And so I started to look at that, basically A's switch with B's switch, which was something kind of like this. And so B is going to go here and here. And I started thinking about these angles. Like there's got to be an angle that A goes through right here, and I called it A, right? So that'd be like the little part here, right? A going to here, to that first, I guess this is B and B prime, and this is A, and A prime's over there somewhere, right? And so A right here, and then I called the other part, kind of like there's two parts of the angle made by A to A prime. There's the part on the left side of the line connecting B to the point P, X, Y, and there's the other side of it here. So I'm going to call this B, lowercase b, and then I thought about that angle must be the same, right? So if I add the angle from A to A prime, B to B prime has to have the same angle because they're rotating, right? A rotation centered at a point. Is the point up there? I don't know, but I do know that the angle needed to be the same. So I just placed it up there for thinking purposes. Again, what are we doing? We're flipping switches, right? If you watch the Amy Mindset, Amy Mindset video. If you watch the Amy Mindset video, you're going to hear me talk about different analogies to approach problem solving. One of them is to flick the switches, which means try everything out. Just see what you discover. Okay, so I said, okay, well then this would have to be A also, and I started thinking about the angles. I was like, well that's A and B, and that's B and A. Of course they must be equal, like we said. But maybe there's some kind of congruent triangle thing. So I thought about if I connected this and has to be isosceles, And that's when it hits you. That's when it hits you if you think about the fact, why do I know it's isosceles? Oh, well, that's because the distance from P to A and A prime has to be the same. Why? Well, because number one, the segment will be the same length after you rotate it. A rotation is an isometry. It preserves distance. But the distance from a point of rotation does not change when you rotate around. It's like a radius on a circle. So when I rotate A to A prime, the distance to wherever P is located will not be altered. Well, then why am I doing this A thing? Why don't we just do distance formula? And that's when it hits you. That's the break in the problem. I didn't see it originally. I got frustrated trying to think about how to approach it. Gave myself about a minute and a half, couldn't think of what to do. So I went ahead and did 20, 21, 22, 23, and 24, and then came back to this problem. And so that's when I discovered this, and I was like, oh, that's kind of obvious. So now we just have to do distance formula with 1, 2, and 3, 1. And you say, okay, well, I don't know what this is. Okay, x minus 1 squared plus y minus 2 squared has to equal x minus 3 squared plus y minus 1 squared. And you say, well, doesn't distance formula need that's not the distance. It should be distance equals the square root of that. Yes, true. But they're both going to have a square root. Why put it? Why don't we just square both sides and get rid of it right there off the top of the thought process and save ourselves the time of writing too much information that we don't need. Next, you're going to go ahead and do the B1, which went from 3, 3, and 4, 3. And that's going to go to here as well. So I'm just going to write it here again, 3, 3, 4, 3, just to write the coordinates. X minus 3 squared plus y minus 3 squared equals x minus 4 squared plus y minus 3 squared. And this is why I didn't go to town solving this right yet. I didn't just start, squaring stuff and moving things around. Just wait, maybe something nice will happen. And it just did. The nice thing that happens is this squared term's going to go away because they're both y minus 3 squared. Furthermore, when you square both sides of this, the x squared parts will cancel. So I didn't even write those on my paper because I can visually see they're going to cancel. I just wrote negative 6x plus 9 equals negative 8x plus 16. Let's move the 8x over here to get 2x, the 9 over there to get 7, and x will equal 7 over 2. 7 over 2. So then what? Now we're going to go ahead and take the 7 over 2 and plug it in to one of these equations, I guess. I just want to do that right. It's negative 6x, negative 8x. Something's bothering my brain. Negative 8x plus 16, 9, 8, 2. Yeah, got to be right. Okay. So then 7 over 2. Now we're going to take that and plug it into, it doesn't really matter, I guess, up in this equation right here. 3.5 minus that is a half. Yep, it's a half. Half squared on both sides. All right, just my brain still doesn't want to let go. It thinks something's wrong. So I'm going to go ahead and take this x and plug it in here. 7 over 2 is 3.5 minus 1 is 2.5. 2.5 squared, 6.25. Or you could say 25 over 4, same thing. 5 over 2 squared. Plus y minus 2 squared. I'm going to go ahead and expand it now. Y squared minus, it's y minus 2, y squared minus 4y plus 4 equals, again, 7 over 2 minus 3 over 2 is, or minus 3 is a half. Half squared is 1/4. 1/4, and then y squared minus 2y plus 1. Of course, we're already thinking ahead. We know the y squareds are going to cancel. I'm going to bring the 1/4 over here to get 24/4, which is 6. 6 plus 4 is 10. And I'm going to move the negative 4y over there to add with that to get 2y. And the 1 over here, which is going to equal 9. So 1 off of 10 to get 9. 9 equals 2y. Y will equal 9 over 2. So now we have our two coordinates. There are these two coordinates, and the positive difference is just taking the bigger and subtracting the smaller to get answer choice E1. That's it for this one. Catch you in the next one.